Hello everybody. So I will be doing chapter 15, which is the data analytics part, which is our tutorial 2. So chapter 15, generating data. Data visualization is the use of visual representations to explore and present patterns in data sets. It's closely associated with data analysis, which uses code to explore the patterns and connections in a dataset. A dataset can be a small list of numbers that fits in a single line of code, or it can be terabytes of data that include many different kinds of information. Um, Creating effective data visualizations is about more than just making information look nice. Um, so people used Python for data intensive work in genetics, climate research, political and economic analysis, and much more. Data scientists have written an impressive array of visualization and analysis tools in Python, many of which are available to us as well. One of the most popular tools is Matplotlib, a mathematical plotting library. So in this chapter, we're going to use that. So we have our first visual, which is dice visual. So this code simulates rolling two dice, a six-sided die and a 10-sided die, like 50,000 times. Each roll adds the values of both dice and stores the result. And then it counts how often each possible total from 2 to 16 appears. And then finally it uses Plotly to create a bar chart that shows the frequency of each result with one bar for each total. And then here we have our die, which defines a die class that represents a single die. So when we create a die object, we can choose how many sides it has. The default one is 6. Then the roll method returns a random number between 1 and the number of sides, simulating rolling a die. And we have MPL squares. So this code uses Matplotlib to create a simple line graph that shows square numbers. It prepares two lists, numbers and their squares, applies a visual style, plots the data as a line, adds a title and axis labels, adjusts the text size, and finally displays the graph on the screen. So let's do this. Python MPL squares.py. Here we go. My laptop is slow, so apologies for that. Okay, there we go. So we have our simple line graph, which shows the square numbers. So our square values are 0, 5, 10, 15, 20, 25, and then we have our values, which is 1, 2, 3, 4, 5. So that is our line graph for MPL squares. So here it shows us the x value and the y value here at the corner, and here it shows the values. Okay, and then we have our random walk.py. So we have our class, our random walk class, So this class generates a random path made of many small steps on a 2D grid. So when the walk starts, it begins at the point 0, 0, and then the fill walk method repeatedly chooses random steps in the x direction and y direction, and each step can move left or right, up and down by a random distance between 0 and 4. And then steps that don't move at all, it's 0 in both directions, are ignored. And then every new position is added to two lists, which is the x values and the y values. And then this continues until the walk contains the desired number of points. So if we run this, oh sorry, no, it's actually not supposed to run that. So our random walk visual is here. So here the program repeatedly generates a display of random walks using matplotlib, creates a random walk object with 50,000 points. It calls fill walk from our random walk.py to generate all the random x and y positions. And then we have it plots those points as a scatter plot. Each point is colored based on its order in the walk using a blue color map. The starting point is 0, 0, which is highlighted in green, and then the final point is highlighted in red. The axes are hidden for a cleaner visual. The program shows the plot. And then after viewing the walk, the user is asked whether they want to generate another one. And then if the user answers no, the program ends. Otherwise, it will generate another walk. So let us see. It's rw visual visual .py. Okay, there we have our random walk visual. So this is our starting point, and this is our final point. And then when we come here, that is supposed to ask us if we want to generate another one, but it's taking time. Okay, we'll come back to it, and then if it shows up here. And then lastly, we have our scatter squares.py, which also uses matplotlib to create a scatter plot showing the squares numbers from 1 to 1,000. So our x values is a list of numbers from 1 to 1,000, and then our y values. And then our y values contains the square of each number, e.g. 1, 4, 9, 16. And then the plot uses solarized light to style. Each point is colored based on its y value using blue color map. The chart includes a title and axis label. The axis ranges are set to so the full graph fits nicely. And then the tick labels are displayed in plain number format, and the scatter plot will be displayed. So let's say Python scatter squares dot py. go. So we have our colored scatter plot of square numbers up to 1,000. Okay, I hope everything was clear. Thank you for listening. I will see you in the next video.